Hello and welcome. This is our second annual presentation from our senior level video game design and development class. My name is Jim Etheridge. I teach the class or facilitate the class. This year we had 20 plus people in the class. I divided them into two groups. We had 8 or 9 programmers on each of 2 teams. We were lucky enough to have 3 visual artists and 2 musicians join us. They kind of served both teams for the music and the artwork. The team spent essentially the entire 16 weeks developing these projects, and I think they've done a wonderful job. I think you'll be impressed with what you see. Let's see what. Oh, before I forget, I want to thank Holly Boudreau. Holly Boudreau is a PhD student. She teaches another of our gaming courses, and she has been helping the entire term. What we're going to do today, I assume most of you are familiar with the program. If not, I can talk to you later. What we're going to do is, once I get finished talking, which will be very soon, each of the 2 teams is going to present their project in about 20-25 minutes. Show you what they did. Each of the programmers is going to talk a little bit about the part they played in the development of the project. That should leave us some time at the end for questions and answers. So feel free at that point, if you have any questions of any of the programmers or teams or me or whatever, feel free to talk to us. That's what we want to do. Okay? I guess we're ready to get started. The first team is the undergrad All-Stars, and their project is called Steamboat. And here they go.
Good afternoon. First up, I'd like to talk a little bit about the group divisions that we got received. There were about half the students undergrads, half the students graduate students. Somehow, I don't know how it happened, the graduate students all formed one team and the undergrads all formed another team. So we were really kind of left in the dark with not knowing anything about framework, and we were all forced to beat it into our heads, which took about 2 months. This was probably the biggest learning experience I've ever had. Everybody that was involved, we had no idea what to do. Didn't know where to start. We found resources to just start reading, finding material on architecture, finding how to design a game, the main game loops, how to get it structured in a manner where you could, I guess, add to it or detract from it without having to affect many different types of systems in the game. Ryan worked on networking. He's the guy that's underdressed. Sam did a lot of miscellaneous stuff. As you saw in the video, he did motion capture. He had the main concepts for the characters, how to, what types of characters we want, what attacks we wanted. Ben worked on collisions. He also worked on resource loading, and he did an amazing job. He was pretty much there with me every night. Devin did our graphical user interface. He programmed the buttons on the screen to do attacks, to interact with the environment, character selection, things like that. Van did the second wave of our character movement. We had 2 different types of movement, and he implemented the better one. Josh did our particle systems, and he pretty much jumped around helping out everybody else. He helped Mike out on the sound as well. Mike did our sound. He was the one that got a 3-dimensional sound where sound in 3D space will actually be less volumetric or have less volume when you're farther away from it. First of all, I'd like to talk about the architecture of the game. I really had no idea what I was doing. I'm not even going to try to make something up. I probably spent about 2 weeks just reading articles, finding whatever I could, just to figure out how to structure the game so that it would run and not blow up instantly. Ryan also was on the networking. We had to do our entire architecture based on the networking. We didn't know where to go with that. Ryan did a lot of research on the networking part. I did a lot of research on the framework. And in the end, we found a way that we could make the two coexist without blowing up. I'm gonna have Ryan come and talk a little bit about the networking first of all.
Yeah, like you said, the structure was complicated. Yeah, so RackNet is a multi-threaded UDP-based networking engine, and it was intended to be application independent and easy to use, which it wasn't. It had, I mean, they have videos and tutorials and stuff online, and it's not exactly friendly. And so we had to delve deep into the architecture, trying to figure out what, where everything goes. So our first goal when we decided to start trying networking was to find out if we wanted to use it server to client based or peer to peer. And we decided after some research that neither one was better than the other, but for our application, server to client would be better. So then we had to decide, you know, who to give control of creating players and everything to. Would we do it on the player side or on the server side? So we decided to make the server create the players and have control over everything. So then we decided to create a player on the server, which was very difficult in the beginning because we had to mess around with C++ and class hierarchy and structure and all that stuff. It was very, very complicated. And that took us the most amount of time. And after we figured out that, everything else like the particles, sending information across the server wasn't too bad. RackNet is application independent, making that in C++ you have different types. So sending generic types over the network and then reading it in the object you wanted to have was very complicated. It was very not easy. So we finally got that, and that took us the longest thing. And then we end up getting chat and everything working. And the final goal was to get interpolation working, which is interpolation when you move, you average your one position from the new position and average it in, making it much smoother. And so that was our last goal that we had, and it turned out to be really awesome. Interpolation is pretty cool. So
another thing I wanted to talk about with the networking is we wanted something that was going to be very lightweight. It wasn't going to have much bandwidth. We wanted to be able to run it on any type of connection. So we structured our packets that sent messages to say create a server, create a player, to be very small, and they were encoded so that when the server would receive them, it says, okay, I can decode this, do this, and send a message to all the other players and tell them to do that. Devin designed our graphical user interface, which is the buttons on the screen, and let's see, can you go to make a server? I'm going to have him talk about what the process was of designing it, how we went about doing it, what all the buttons actually do.
Basically, we wanted to keep our steampunk design with the gauges, the meters, little things there. Up here, we have, which didn't make it into the field, but basically these are HP, TP, and guard meters, which what they'll do is they'll receive a value from the server and then update the image based on what your HP or what your guard and TP is at that kind of time. It will display that image accordingly. Right here we have the chat box, which anything you type here, it will send to the server with your username, your text, and it was broadcasted out to every single user playing at that moment. Right here we have all the buttons, which basically does everything that what you can do with the keyboard, except you're not reliant on the keyboard, where you just click these buttons and it will do the ability that you want it to do. As well as we also, which you can't see right here, which we're targeting, is when there's a player on the screen, you can click on the actual player and it'll find the closest one to you and target it. And then from there, that's how you do all of your abilities, either from the keyboard or the GUI.